Hello there once again, friends, ladies and gentlemen. You'll notice that I'm looking at my stamp collection wallpaper, and I realize that I'm missing someone in here, someone I wanted to mention in this video, and I found two stamps with Carl Friedrich Gauss. Here's one of them. This is the bigger of the two. But maybe I can slip it in here somewhere. It's not really big. Maybe I should resize it. Or maybe where I found it has a bigger size. This is not a stamp. Now this is oh yeah, okay. Right, 721. So this is the one I wanted. That's a nice big one. Okay. Get ready here. And I'll take the big one. Now that's too big. 600. Maybe I'd like it around. Let's see. About this height. 200, 250. Now see, I've got two with Picasso, and we certainly don't need that. So I could fit here. A little bigger. Try 60. It's pretty good. It's a little bit bigger even. That's a bit bigger. Try 275. Okay. Now, I don't want that black. I could do it, but actually fill it with something else. Now, how do I just float that? How do I layer that selection? Okay. Let's see. So that can stay where it is. And this selection is in So 1, 2. Oh, right. So for the selection, I should modify its transparency a little bit. What I like. Now underneath there, I can fill this entire selection up with black, say. I will delete that and don't we'll keep the selection and okay. Now selection. Oh, that's at 100. Now how do I change this back? Start from the beginning. Easy to do. What I do is I do what I had, selected that, and I don't really want that selection, I want a square, but I need a new layer. Now everything's fine, I can hold this away, and select that area. Select this tool, and say that, delete, fill it black, solid black, no alpha, everything back, and now you just go, oops, like that. But underneath there should be a background. I didn't delete that. Oh, right. I forgot again. So this here is adjustable. Make it look nice. There, like that. How does that look? There he is, Carl Friedrich Gauss, who I'm certain that you've heard of, at least the name. With Gauss. Yeah, well, here, you want to see Gauss's name show up? Suppose I want to blur something. Oh, I'll try Gaussian. Same guy. And often things to do with statistical things will have its name show up. An example here, add noise. One way of adding noise is to use a Gaussian noise distribution. And that's because Gauss did a lot of work on statistics and averages and so on. But his primary contribution to mankind and human knowledge has to do with the theory of numbers. Now, where did I put that? With Gauss. Yeah. Let's try putting that. And the reason Gauss came up is because of this thing that now this tutorial actually I just realized that this tutorial is going under the batch file tutorial. So the person watching this may not realize that I spend a lot of time on my wallpapers. In particular, this one with the stamps contains a collection of either famous figures or famous entertainers or whatever throughout history. And for instance, I've talked about Tycho Brahe and Galileo and none of the others yet. Oh, and Patsy Cline I've talked about. Now the reason Gauss comes up is because I just wrote a computer program to do with the title of this video. I wrote a program in C++. Now you may not know anything about C++, but I'll just show you the idea. Take a directory here, right? My goal here, in the batch file that I want to write, that I've already written it and I've already run it and it works, is what I want to do is I want to walk through all these files and find out if any two of them are the same. Okay. Now I could probably make the whole process a lot speedier by checking file sizes and so on. But just generally speaking, it would be nice to be able to walk through all of the pairs of files in a list like this. Okay, so how many files have we got here? It says 23 files, 9 directories. Now, does that make sense? Lines equals 25. I still want some extra height here. Alright. Now in terms of files, this is of height 25. There's certainly 23 files, right? And currently 9 directories. 1, 2, 3, 4, 5, 6, 7. And these two are always there. Except for in the root. There's no dot in the root. So that answer is correct. Go back to how I like it. Now, here's the question. And this is something, this is why Gauss came up. Now, was it to do with the? I guess it's the same. It's the same problem. One of the famous stories about Gauss is that when he was a child, and before he was known to be a mega genius, and that was where he came from a very poor family, and he was forced to go to the regular school, and the regular school had a regular teacher who regularly harassed the children by giving them, especially like in the math class, some extremely long problem that would take forever, and just to keep them busy so that the teacher could just, sit back and smoke cigarettes and not have to do anything for an hour. And one of the problems given was by that instructor, who ended up actually becoming a benefactor, I guess, for Carl. That is, he recognized that he had a gift, and he did what he could to make sure that he was sped ahead and gotten into a good school. One of the problems was something like this. The teacher would go on the blackboard, and then he'd write down a sequence of numbers. Okay, let's say that's the first number. Okay, and the second number would be this plus a fixed amount. So how about this? Delete me. Set num equals that. Set increment equals, it could be any number. 237, let's say. And then go up to a big number, like 100. So now that should add, and now I don't know if this is going to work on one line, but it might. So that should add the increment amount, and then echo out the number, and do it 100 times, and we'll get a list of 100 numbers. Not so many. Let's see. 30. Something that would keep the kids busy for an hour. 50. Didn't know. Right. Next. Set num equals to num plus increment, echo the number, and that should be increasing. Okay, that's changing, definitely. Maybe it was before, and I didn't notice. Alright. So the teacher would write this down on the blackboard. Could have done that in the batch file. Whatever, a lot, right? And then at the end, and the kids were told, so he would fill up the entire blackboard with a big list of numbers like this, and the students would have to add all these up, and then submit at the end of the hour the final total. Okay. Now Gauss. Legend has it, our friend Carl looked at this problem, thought for a few seconds, and wrote down the answer and handed it in within less time than it took me to explain the problem. Okay. And now he'd never seen this sort of problem before. He noticed that the differences were equal, and so he immediately realized how to perform the sum, how to turn that into a single expression, and he was able to work out the expression in his head, and so he just wrote it down. Now, can I do this? Maybe. I need a better editor. We shall put this in, where am I? There. Okay. Now, the reason I wanted it here is because I want to make a keyboard macro. Let's see now. Suppose I'm on this line. I would want to go down one, backspace, home, and done. Just trying to replay the macro. Okay. Now this. I should be able to do this. So here's the answer. 5, 6. And so he just wrote that down. Whoops. Okay, here's the answer. And the teacher, of course, immediately thought that he must have been joking, right? The teacher didn't even know what the answer was. He just wrote this problem down, and he was doing the adding of the difference along the way until he got bored enough and stopped. And then went off to do his thing and let the students work at it. He assumed that Gauss was just joking, and then he worked it out, and he added it all up, and it came up to that number. And of course he was quite astonished. And he asked Gauss how he figured it out. And Gauss explained that quite, just, well, obviously, since the difference is the same, it's, what is the difference? I've forgotten it well. Good. I get rid of all the rest of this. Delete. 237. So he realized that the difference between each of these numbers is 237. So we have 16824 plus, and then it's going to be 16824 plus 237, right? And then plus, same thing again, and another 237, and so on, right? All the way up to however many of these there are. Call that n. How many are there? This is line 1. This is line 28. So let's say there's 28, right? 29. Here there's 1. Here there's 2. 28. So there are 28 lines, and so there are 27 consecutive additions of 237. And so the answer, therefore, is 1684 plus, and there are 20. And 270, so 237. And this should have been 28. And there it is. Okay. 560658. So here's what he worked out in the formula he worked out in his head. And computed in his head at the age of about, well, kids are learning addition around grade 5 or grade 6, so he would have been 10 years old, 11 years old, and he did that with no training in mathematics or anything, just by simple reasoning. This is just obvious, right? That's the answer. And the instructor didn't understand why that was obvious, and Gauss carefully explained why this has to be the answer. Not using any formal mathematics or anything, but just by simple reasoning. And I don't know exactly what reasoning he did use, but all of this has to do with how much time have I used? Well, maybe I'll maybe what you see of this will have a lot of something of the previous bit cut out. Definitely, that's what it's going to be. Now this has to do with the same problem here of comparing all of these files. I'm looking for duplicate files. And so what I need to do is get all of the pairs of files, all the possible pairs, and compare each possible pair, without duplicating any work. And so what I need to know is how many pairs of files are there in this list of 24 files. Okay. Now the problem of finding out how many pairs of things there are is the same as this problem. Suppose here it's New Year's and everyone's toasting the New Year. The New Year just happened, and you want to calculate how many glasses clinging together sounds would you hear, right? Suppose you got 5 people. So we got person 1, person A, person B, C, D, E, and F, right? So A and B will clink glasses together. So now A and B are done. And then A and C will clink together. So we have A clinks with B, A clinks with C, A, D, E, and F, right? Now B already clinked with A, so B will then clink his glass with C, and B with B, and B with E, and B, and so on. C, D, C, E, oops. Etc. And this goes down to just 1. B, E, D, F, and the last one, E, F. Now what you have here is the number of clinks is 1 plus 2 plus 3 plus 4 plus 5. Right? And that's the same problem as this. Because if you factor out these two 37s or whatever, what you have is a 1, disregarding this first one, from here onwards, it's 16824 plus 237. Okay, now this is figured out times 27. And this is 1 plus 2 plus 3 plus however many there were. So it's the same problem as figuring out this sum, right? The enumerating is, well, at least to getting the number of pairs is the same as figuring out this sum. Now I remember I made a little proof of this. I remember thinking of various ways to prove this simple number theory thing. And of course the answer was known at this time. It wasn't anything new, but for a child it was difficult. And I came up with my own answer just thinking about it. And I tried to use the Google, you can write code, you can use this Gmail text, and I tried to make it look nice. But eventually I went to this code cause, and I made a picture using the code cogs CodeCogs is a website. If you click on the help here, it tells you to go to CodeCogs, and I put my equation in and I saved it as a GIF file. Where was it? In these pictures. I have a new pictures directory. Miscellaneous. CodeCogs. Okay. Here's my proof. Yeah. Let's try to make it look nice. Now, suppose you want to figure out the sum. This is totally unrelated, but it's of interest. If you want to impress your friends, you can show them this proof. Suppose you want to figure out this sum of the numbers from 1 to n. Okay. Now, one way to prove it is the following. Take this sum and instead of adding it from smaller to larger, add it in reverse. So that doesn't change the sum, right? So this sum is the same if I add it in the reverse order as in the normal order. Now take these two summations as they are and add them together. The first sum is 1, and then 2 can be represented as 1 plus positive 1. Now I use these plus signs to make things line up. 3 is 1 plus 2, and so on. And n is 1 plus n minus 1. Okay. In the reverse order, n is n plus 0, and n minus 1 is n plus minus 1, and so on. n minus 2 is that. And you can see that if you add these two together, this term gives you 1 plus n. This term also gives you 1 plus n because these cancel. Similarly for all of them. In every case, everything cancels. So adding these two together, twice the sum is n plus 1 repeated n times. So therefore, the sum is 1/2 n times n plus 1. And that's what he worked out. Okay. What's that got to do with the file thing? Well, the program that I wrote that I showed you here, utest, is doing a thing like that where I'm walking through the files and enumerating them without, I don't want repetitions, so it's like those clinking glasses, and I want to print out all of the pairs of files that exist given us some specifier. And I called this program still in history somewhere. Get file pairs. So I'm going to say star.star, and that's all of them. Okay, in this directory. It's including hidden files, unfortunately. You could take a simpler directory with some hidden files. There's something called temp here. I assume I can delete everything here. No, make another temp. No, it says temp, I can delete it. Subfolders, but that's okay. Alright, and now I've got 24 files, nothing, no hidden files. And I'm going to run that same thing to give me my list. You still can't tell how many there are, can you? Let's see, I'll put that into the clipboard. Here's line 1, the last line. So there are 276, turns out, pairs of files, and they're indicated here, delimited by a semicolon. So the first comparison would be this against this, the next this against this, and so on until we're done that set, and then it moves on to the next file in ever decreasing amount, and we get a total number of pairs, as I just said, 276. Now I had to write a computer program to do that, but I figured it can't be that hard to write a batch file to do the same thing. After all, I mean, it's just a matter of walking a file list and not, backtracking. So I did. And it's called not that Delphi. Generate file pair. Alright, so now here's my algorithm. The file specified, the file spec, %1 is what you pass in. If you don't pass anything in, it'll be star.star. It'll default star.star. And now I'm doing for /f in this command, which is a directory command, bare format, not including directories, file spec. And I didn't know what to call this, so I called this something. So we call something with the answer. The answer might have spaces, so I put quotes. Now I'm at something here. I'm calling that the beginning. That's like our anchor, beginning location. And I'm setting something called started to false. All right. Started meaning we're starting. We're going to start echoing things. Now I'm doing the same thing again, and I'm calling something else. This time with the argument that was passed in, which is our file begin, right? And the result from the same directory command. Now something else checks to see if actually I need a variable here. It should just check to see if %1 equals %2. In fact, that would work too, wouldn't it? Let's try that. Forget about file begin. So if this thing is equal to this thing, that means that the thing passed into this something is equal to the thing that we just hit, right? Then I'm going to say, okay, now it's time to start printing. So when they're equal, and I don't print anything out in that case, maybe I'm supposed to. When they're equal, how am I going to print the first one out? How does the first one ever get printed? So maybe I gotta print the first one too. Okay, well, let's try. No, but I compare them. It's the same. That's right. No, we never want to. We want pairs of things that are different. That's why I'm not printing it out, right? I don't. Obviously, two files that are the same file are going to be equal. I want the pairs of different things. So I set start to true, and go back, and then from this point onwards, it's going to start printing things out, because the next line says if started is equal to false, go to the end. Otherwise, echo out our current directory and then the two file names delimited by a semicolon. Did I get rid of everything to do with that funny variable? Just started, right? So now I can say gen f pairs. It's a little bit slower, but it does generate the same set of pairs. Speed is not important, it turns out. And the reason I want this is the following. I got this directory. Not that one, this one. I got several directories like this. Now, I don't know about this one in particular, but these are icons taken from either DLLs or exe files or whatever. And a lot of them are duplicates. And I want to get rid of the duplicates, right? Now I don't want to go through and check every single one by hand. Okay, this directory, image res, is not so bad. It only has 428 items in it. But this directory has, it's not finished counting yet. Okay, now I've already reduced this, by the way, significantly. So it used to be about 27,000. Now it's down to 23,000. And a lot of these are duplicates. In fact, tons of them are duplicates. They're just the same picture. These are probably all duplicates. And what I want is that I want to run a batch file. I don't care how long it takes. I'll let it run in the background, and maybe tomorrow or someday in the future it'll be done and all the duplicates will be gone. That's what I want. So here's my match file. And I forgot what I called that. Clear duplicates. Something duplicates. Find dupes. Find dupes.bat. Okay. How's that work? No, it's calling the get file pairs program to generate the list of pairs. But now I have a batch file that does that. So I just need to modify this. And then what it's doing is it's using the built-in file comparison program, FC. Where is that done? FC, okay. Well, there should be a /b there for binary. But anyway, it's not important. And it turns out that this thing, FC, sets the error level to 1 or 0. When the error level is 0, that means the files are the same. In which case I echo out the fact that I found a match. and then I delete the first one of the set. And the reason for doing that is that it allows me to save off the last file deleted and skip all the other matches that were found with that file until we get to the next one. You see, after I've deleted that file, then I don't need to check for any more matches with that file because it's gone. But this thing, you can't stop this thing from doing its walk. So it's stuck on one particular item, right? And going through the list for that item, which happens to be the first one. This is the one that's being repeated. So I know that the next few lines are going to contain that file, but no other ones are. Just as in this linking thing, there are no A's in this next one. So I find a match here, let's say, and I want to ignore these ones, and then by the time I get here, I'm not going to see any more A's. So that's what I'm doing here. Taking note of the A, and if the next comparison includes A, this is just a guard against the emptiness. The letter A here could be anything. If %1 is the last thing deleted, skip it because it's been deleted. %2 will be still possibly existing, files. And then that's it. Now, this process actually uses up quite a lot of CPU time if it's let to run as fast as possible. So I put a sleep here. It's supposed to be 10 milliseconds, but any amount of time helps. And that it slows the whole thing down. But I don't care about how fast it goes. So it allows the system to behave to behave in a normal way without having all of the processor time dedicated to this job, which I just want to occur in the background. Now I can use this. I don't know how to use my batch file. Could I do call? Maybe try. Cool. That thing echoes out the same result as this thing. Call gen pairs %1. Now let's see if it actually works. I need something that has duplicates. I have an example. I had an example. Something with duplicates, but I can easily generate something. Okay. Let's just say copy anything. Done. Okay, so there's a duplicate. There's at least one duplicate. And now I'm going to run my program. Find dupes. Find and delete dupes. It's not compare. What will it call? Gen pairs. I don't know if this will work. No, it's going. See, look. Now it should have deleted this file. Oh, it's just finding. It's not including the D. I have to do /D to delete. Now you'll notice how slow it is. It's going through those 200 odd things. If I put a /D at the end, see, if delete matches is true, then it deletes. And that's true if %2 if A%2 equals A/D. Let me make that insensitive. Should work with a little d. See? Now the one that deleted is the one on the left. Otherwise I'm going to be matching extra things. So that gets rid of duplicates. And now you see how long it takes to go through this small list of files. Imagine how long it's going to take to go through 23,000 files. But it doesn't matter how long it takes to go through 23,000 files because it's in the background and eventually it'll be done. Maybe tomorrow sometime, maybe next week, I don't care. But I could try it on this image res and see how long it'll I think there are certainly duplicates in here, even though these are from the same DLL. You can try. Find dupes and delete. Now this is not using any special program, purely batch file and the built-in file comparing program FC. And if it finds any duplicates, it will delete them. Now the question is it using that processor? So the sleep should slow it down. And it's not even noticeable, right? It should be this way. One of these commands. It's hard to tell. Is there only one? There's only one. Okay, well it's quite high, still 20%, but it's better than if I didn't have that sleep. What I can do is I can do what I normally do, put it off on the side, forget about it, let it do its job, get a new box, and that's it for that. I'll try to turn this into a video. See you. I'm just tacking this little bit on the end here. Here is the video that you're watching or in the past. Here is the folder image res, which I ran that batch file in. And you can read here that it indicates 428 items. That batch file completed its task. Actually, I cheated. I sped it up using this C program to make it go faster, so that I could have an answer for you at the end. Now that's under here, and it now lists 210. So more than half of these icons were repeats, were identical to some other icon in the list. And it just completed just now. It took a couple hours. This one is going to take probably a couple of days to complete. And I imagine it's going to find many matches. Okay. Well, I hope you enjoyed that. I did. See you.